Hello everyone, Reza here with another Unreal Engine tutorial. The ability to add motion to your materials is an important skill to have, and knowing the right technique can provide a way to create inexpensive and effective effects inside Unreal Engine 5. In this step-by-step tutorial, I will go over multiple techniques to show you how to add animation and effects to your materials without inserting a single keyframe. It's quite a unique tutorial in a way, and we have a lot to cover, so let's get started. All right, let's analyze the scene really quick. This is the model that I would like to bring to Unreal Engine 5, and it's basically a spinning wheel game. I've got 3 green parts, and these 3 green parts will give us an excuse to learn more about certain techniques to add animation to materials. So this is a Wheel of Fortune-ish type of model, and I do have a material for it. So this is the material that I would like to assign to this bit, and I would like to spin it using certain techniques. This is a sort of a notification board that I have. I've already made the font ready in Photoshop. I would like to assign it to here and pan that font across the board. And of course, I would like to use Math Node to create flashing lights or to create a transition basically from one color to another color. So 3 different objects, 3 different techniques. Hopefully we kind of killed a few birds with one stone using this model. So let's export this to Unreal Engine 5. So send to Unreal Engine, and you can go selection, or you can export it as FBX or OBJ. Just something to be mindful of. We've already gone through this via introduction to material video, so feel free to check that out. But just to do a little bit of recap, make sure smoothing groups is on, and of course when you export everything, if I go all the way to axis conversion, make sure up axis is set to Z. With that in mind, let's export this object into Unreal Engine 5, and we'll take it from there. All right, here I am inside Unreal Engine 5. So as you can see, there is no material on these 3 guys. The ground plane is just a default plane. What I did, I've gone ahead and created a new level and gave myself a basic level and saved that level as Wheel of Fortune WOF into levels. I put all the materials in here and all the props that I imported to Unreal Engine 5 into a separate folder, and these 2 textures that I've got, the Wheel of Fortune texture and the font, Do You Feel Lucky, I brought them into their own folders. So I've got textures, props, materials, and levels, and I've got one finished one for the ones that I've tried before. Nothing new. For the materials, all of these materials are just untouched, brand new materials. I didn't do anything because I would like to show how to add animation to them. So as you can see, I just named them correctly. So MM for master material, will, which goes to this guy, and then I've got MM master material button, which goes to the button, and MM board, which of course goes to the board. Now with that out of the way, and by the way, I've covered all of these steps in my previous videos, so please feel free to check them out if some of these are sort of vague or unfamiliar to you. But with that out of the way, let's go to the first chapter and learn how to add rotation to this spinning wheel. All right, we already have this MM wheel assigned to this object, but I actually would like to assign a material instance to that object instead. So I'm going to create a material instance. So we keep this master material, we put some attributes on to this material instance, so it makes the job a lot easier. It's easier to compile, and we've already tried this in the past. So mi for material instance, wheel, and what I'm going to do, I'm just going to drag and drop that here, so we know that what we have in here is just a material instance. Now I'm going to double click on this wheel to open the material graph. I can go full screen for now. So let's start by adding the texture. I've already imported the texture here. That's the texture that we have, and we know how to add texture hopefully by now. Simply drag and drop it into the material graph space. So there's nothing special going on here. We've already tried this in the past, from RGB to base color, and we get ourselves a texture. I'm going to apply that. And if I minimize, you can see the sort of Wheel of Fortune texture has been applied to the material. And again, we're not looking at the master material here, we're looking at the instance. So keep reminding yourself that the instance is the one that I'm looking at, but it's identical to the master material. Again, if those two and the notion of master material or instance material doesn't make any sense, I've got a separate video just on those. But basically, instance is a copy of master material, and it's much faster to compile. That's why we use instance instead of master for every single material that we use. I'm going to save for now, and let's see what else we need. I'm going to maximize the window. So next is to bring a node to allow us to create rotating textures. Now that's the exciting part, probably the easiest part of the tutorial. There is only one node that can rotate textures for you without adding a single keyframe, and that is called Rotator. That node is amazing. It's got two main nodes. One node is coordinates, from where you would like to rotate your object, or your texture rather. So you need to give yourself a coordinate. You need to know where the pivot is in your model, and of course it is a time dependent node, so how fast this needs to be rotated, that's another thing to be mindful of. So there is a node actually called time, and that gives you a passage of time to the material. But surprisingly enough, if you just go from coordinates to UVs, you can actually have a rotating material. So I can just go apply, and if I go in here, you can see now the texture is spinning without even using this time, simply because we've got actually the time here. We've got the coordinates. Center X is your U, and the center Y is your V coordinate. So U, V, and it's at the center of the texture, 0.5, 0.5. And that's why it rotates from the center. And we've got speed, and that speed determines how fast this object or texture is moving. So if I go in here and set this speed to 1 and apply, you can see it spins a lot faster. However, while it's working, we would like to parameterize this time factor so we can have it as an attribute in our material instance. Right now, there is no way to have this or extract this as a parameter in our material instance. If I double click on my material instance, there is no time factor here, and we have no access to the speed. There is no way for us to tweak that attribute, and that kind of defeats the purpose of having the material instance. So let's see how we can, in a very, very easy way, extract this time factor using the actual time node. So I'll make sure that everything is default. Again, if you change anything, you can click on this reset button to bring everything to default. Now, basically, all you need to do is to multiply this time factor by a constant and give yourself a parameter. Let me show how this works. So I'm going to press M and left click to create a multiply. Of course, another way is to just typing multiply and bring the multiply node, or bring it from the main palette. It really doesn't matter. I'm used to the shortcut, letter M on your keyboard, left click to bring multiply. Now that output goes to time, and time goes to A. We just need a single constant expression to be able to control the value. So single channel expression, we already know, one click and it gives us a single channel to the B. And now this is something that you can parameterize. I'm just going to right click on it, convert to parameter, and I'm going to name it rotation speed. Now this can be seen in our material instance. That's fantastic. And if you look at the default value, I've got default value set to 0. I can set it to 0.25, the value that we had in our original rotator node. But now this can be seen in our material instance. If I go apply and save and go to my material instance, just going to go and open my material instance, we can see now we have rotation speed at our disposal. I can go ahead and enable that and bring this window to a side. And now all I need to do is just to change this value. So I can go and set this to 2, set this to 4, set this to 8, and you can see how dynamic this looks. No compiling, no saving, nothing. So really simple way of animating or rather rotating your texture over time using a rotator node. Again, it relies on UV coordinates. So if you're planning on using this node, make sure you've got good UVs. Very, very useful, very easy to use. So let's move on to the next chapter and explore more techniques. All right, next is to add animation to this notification board. In the previous chapter, we learned how to rotate. Now we learn how to pan a texture across the model from left to right or top to bottom, or maybe diagonally if that's something that you want to do. To do that, we need to, of course, create the instance. So I already have the board. I'm just going to go create a material. I'm going to rename that to MI board. I can probably minimize this and dock that, bring it as a floating window, and just drag and drop it onto this board. That definitely works. And if I double click, you can see that there is currently nothing in there. We do not have any parameter, and that's exactly what we want to get. So I'm just going to go ahead and open the master material, and there we have it, our master material. First things first, of course, we know what to do. We need to bring in the texture. So I'm going to go to textures and bring over my texture, RGB to base color. And I preferably would like to add that to our emissive as well. That can be fun. So maybe actually emissive will get the job done. So Alt to disconnect. I'm going to select this guy and I'm going to go to shading model and change that to unlit. With that, we're not going to get any of these expensive nodes, no specularity, no metallic. This is just a notification board, so maybe just emissive will get the job done for us. So I'm just going to connect that to my emissive. We really don't need anything else. And already try to be careful about my material. So if I double click on it, you can see the background is already black. The font has already been colored. I'm not going to change anything in here, which is good. So let's start with the actual node. Now, the node that we would like to use is called panner expression. Now, the panner expression is extremely useful. I'm just going to go and type in panner. and bring that node over. Another way of bringing this node is to hold down P and left click, and that will bring Panner. And of course, if you would like to torture yourself, you will find it here, but we don't want to do that. So yeah, I think P left click would be the fastest way of bringing this. Now, just like Rotator, this relies on your UV coordinates. So first things first, you need to check your UV coordinates, make sure you've got healthy UV coordinates, no overlapping, within 0 to 1, all the ground rules apply. We've got coordinate, so it takes in base UV texture coordinates, which we've already know how to bring. Its texture coordinate that gets plugged in here. We've got the time factor, and that again takes in the value to determine the current position of the texture, and the time expression would be the right node to plug this to. And of course, we've got speed, and that speed clarifies how fast the object is moving. And you may have noticed once I hover over this, it says vector 2 speed scale. This means that we have scale Y and scale X. Very similar to Rotator, it relies on 2 vectors, 2 values for U and V. U is X, V is Y. So with that out of the way, let's see how we can use this. So first things first, I need to clarify the coordinates. So I'm going to go texture, coordinate. Of course, we already have the UVs all set up. So texture coordinates goes to coordinates. That's very easy. Time factor, we already know this. We can bring in a passage of time and assign that to our time. And for speed, that's the part that catches people off guard. Some users tend to just say, okay, I'm going to grab this guy and bring it over. That is not going to work, simply because if I hover, it says vector 2 speed scale. So we need 2 of these guys. One is responsible for X, the other one is responsible for Y. It also allows you to not only move your texture to left and right, but also move it up and down if need be. So this tells me that I need 2 of these guys. I'm going to bring this one over. I'm going to parameterize both of them because I would like to have them on my instance. And I'm going to name this properly. I'm going to call this speed X. And I'm going to call this speed Y. Now, how will I be able to connect these two into one channel? And this is something that we have already covered in our material video, but in case if you haven't watched that or if you forgot, there is one node that can actually coordinate 2 strings together to make one new string, and that is called append. So append vector is just a right node for me because it allows me to connect these 2 nodes into one and just create one channel out of it. So one goes here and one goes here. That's fantastic. I can select all of them and press C, and I would call that panning speed. And that's something that I'm going to see in my material instance. You can also go in here and, if need be, again, this is not mandatory, but sometimes you have a model where that requires tiling. If that's the case, pressing M, click, and bring a multiply in instead. Going in here, apply the multiply to your texture coordinate, and then give yourself a single value for tiling. And I can just go in here, parameterize it, and just call this tiling. Again, you may or may not need this. I probably don't need to do that because I was kind of careful about my UVs, but if you think that this requires tiling, again, we've covered this already, but just in case, we're going to call this texture scale, and that is responsible for our tiling. This is responsible for our panning, and I just need to call that tiling, and that should do the trick. Now all I need to do is just to plug the coordinate to my UVs. I'm going to go apply, and let's see what we get. I am going to use X, so the font is going to go from left to right. So I'm going to go with X and default value set to 0.5. Now there's one more thing that I need to do before we call this a day, because so far we are not seeing anything, and that is to give our tiling a value, because the default tiling is set to 0. If you don't use multiply and just connect this to your coordinate, you will see the panning happening. But because I used multiply as single value, and usually for a single channel constant the default is set to 0, this means no tiling, no animation whatsoever. The default for this should be 1, and as soon as I click on that, we will see our animation. Fantastic. So now I can go to our MI board and go to speed, and I can either lower this or increase the speed and have my animation. Super cool, isn't it? I can at the same time click on this guy and bring over our instant wheel material and give that a value. And so far we've successfully completed animation on 2 items. Now in the next chapter, we'll learn a completely different method to create animation, changing colors for our sort of winning button. So let's move on to the next chapter. Now let's create a material to change colors on this button right here. I already have a button for it right here. I'm just going to right click, go create material instance. I'm going to keep the name, remove inst, and go with mi material instance, and drag and drop that onto the button. We can see mi button has been assigned successfully. Now let's go ahead and open button. So button, double click, open, and we are going to use a different node to add animation to this button. Now you really need to kind of clarify what you would like to do, but for flashing lights, I think the easiest way of animating this is to use either sine or cosine curve or expression. So if I do sine, or you can do the same thing with cosine, you can see these two expressions, basically they create sine and cosine wave over time. They're fairly similar. The only difference is cosine expression is got a bit of an offset compared to sine, but they pretty much generate this type of node. Let me just bring this over so you can see the output is like a continuous oscillating waveform by connecting this to a time. So this goes up and down consistently over time, and again the only difference between this and cosine is the offset. So where the sine is up, cosine is down, and the other way around for all of these waves. There's not much to it really. You can use sine or cosine, but what it does basically, the output, the input that it likes to get, you may have guessed it already, we really would like to assign time to it. So because it's so dependent to this time value, they always go hand in hand. So if I just preview this without doing anything else, so go in here, enable, and start previewing, you can see that's all it does. It creates up and down value over time. So you can go and change the period from 1 to 0.1 to go super quick, or go to 5, and that's what it does. Extends or widens the waveforms. So that's really it. There is not much to it. And we are using this not as a base color. I really don't want to give this up and down, or 0 and 1, or on and off, or black and white, whatever you want to call it, as a base color, excuse. I would like to use it as a mask. So once you put that as a mask, then you can just have full control over your channel A and channel B, and control your base color however you would like to control it. Now here's a question. What node can we use to have channel A and channel B and sort of an alpha to plug this to the alpha so we can apply all of them to the base color? Well, we discovered that node in our introduction to material. It's a very useful node and perfect choice for moments like this. And that node is called linear interpolation, or a lerp node. So lerp node is fantastic because it gives us the alpha, and that alpha can go to sine or cosine. So this can be offsetted. And then you can just apply textures into pipe A or pipe B. You can apply colors to pipe A or pipe E and have that transition. So every time we get black, it goes to pipe B. Every time we get white, it goes to pipe A. You can reverse that as well. But basically that black and white interaction is our animation for A and B. Now, for now, we are going to use 3 vector constant. So holding 3 on the keyboard, Control C, Control V. One is going to be A, one is going to be B, and it's going to toggle between the two using this guy over here. So in our case, our A is going to be, I don't know, red maybe. And you can actually not have B if you want to. So if I go in here and just plug that, you can see that it gives us a basically white color. You can bring a multiplier, bring the multiplier in here, assign A in here, and you can give a constant to B. It now switches from the color to black to color to black. By the way, I can assign that to emissive color as well, makes it fun. So that's another way of doing it. So now you can see I'm getting flashing light from one color to black to one color. But what I actually would like to do is to have 2 colors. So I'm just going to give this one color for A and 1 color for B. I can probably change that to something else. Let's say yellow. And now we can see there is a transition in here where it transitions from this color into this color, right? You can have a much stronger transition using a multiply for your sine curve. So I can go in here, press M, bring a multiply, holding control, connect this guy into A, bring it over to alpha. So 1 goes to A, 1 goes to sine. The other one can be just a simple instance, and that is the multiplier factor. So I can go in here and set that to 3. And now you can see we are getting a much stronger transition, right? So that's definitely something you can do. If you would like this to be really pronounced, you can always multiply the value, get a much stronger value in here. Now, it is at the moment translating, or basically going, that interpolation is quite smooth from color A to color B to color A to color B. It's more like a dissolve than a linear interpolation. So if I were to sort of draw this right now, it goes to color A and then B and then A and then B and then A and then B. So this is A and this is B. And that's how it works. It's because of the sine curve and because of the lerp node and the nature of the lerp node that blends the two. But it's more about this sine curve that gives us this type of motion. How about this? What if we want to go from A to B to A to B? So what if we would like to kill this smooth transition from A to B and go fully stepped mode? We call this stepped as opposed to spline. There's one node that can help us to sort of eliminate that really smooth transition and go fully stepped with my changing colors, and that node is a material function. A material function is like a bundle that keeps all the nodes in it. We can create our own material functions, but this one is ready to go for us, and it's called value step. So if I right click and type in value step, that receives a gradient, which is exactly what we have here. We've got a smooth transition gradient. So I'm going to get the multiply and feed it to my gradient, because that's exactly what I have. And of course we need to give this a value, a constant value for the offset. So let's say 0.5 offset, and that should work for us. It receives a gradient and spits out a step value that now goes to my alpha. And now if you check, you can see that I am getting stepped value. No transition is happening. My multiply is a bit too high, so I'm probably going to set that one to 2. And now if I go and apply this and look at my button, you can see it no longer transitions from one color to another color. It actually changes on spot, which is kind of more realistic and towards what I would like to see. All right, what about parameterization? What we should be parameterizing here? Of course, I would like to have control over my colors in my material instance. So I'm just going to call this one color A, and I'm going to give this one a parameter and call this color B. And that would be the base color. I can probably go in here, select, and press C to comment it and call this colors. And just in case, you can always group that as well. So I can group this colors, so it's under this group. And for the speed, of course, we have this little guy over here to do the speed for us. Convert to parameter. I'm going to call this speed, and that is in charge of our flashing light. So this is our mask. So I'm just going to call this alpha. This is our alpha that controls all the white and black mask information. And this is our value step offset. So you can actually parameterize that as well. So I'm going to call that our offset value, which can be handy if we were to use it. So that's pretty much it. That's the node hierarchy that we're using. I'm going to go apply and save. And if I minimize and bring up our material instance now, if I go in here and open our material instance, you can see I have control over colors, I have control over speed, and oh, I forgot to put color B under the same group. So I'm going to select this guy and maybe this guy and put that under the colors group. So both are under the same group. Switching back, and yep, I've got both of them under the same group, and I've got speed and offset under another group. We can call it whatever is comfortable for us. So for example, for the speed, I can put that under parameters, and this offset can also goes under parameters group, just to be more tidy about everything. Now we've got colors and parameters. I can go in here and change the speed, set that to 5. You can see it flashes faster. With colors, you can change the color. For example, go from here, and of course color set to green on this guy. Again, if you're unhappy about emissive, press Alt and disconnect the base color, so everything goes directly into emission. I'm going to save, and now what you see is going to basically just show the emission color, and at any point of time you can change that to any color that you wish to have. Again, you can add more colors, pretty much the same rule applies. You work with the exact same workflow, but basically that's pretty much it. So we discovered 3 different ways of applying animation to our scene, using rotator, using panner, and using sine or cosine into animation, and that gives us really a cheap way of adding motion to our textures. I hope you found this video useful. I hope you use these techniques in your own projects inside Unreal Engine. Thank you very much for your support. As usual, you can always follow me on Twitter or my Instagram channel to know more about all the upcoming projects. Have a great rest of your day, guys, and see you in the next video.